welcome to the IoT podcast show. Today I am joined by Jan Jongboom. Jan is the co-founder and CTO of Edge Impulse. Edge Impulse are the leading development platform for embedded machine learning, used by over 1,000 enterprises and over 10,000 projects worldwide. Jan is a technology evangelist. He has a fantastic background in embedded engineering and has written thousands of patches for open source projects. Jan, thank you so much for joining us today on the show.
Wonderful intro, Tom. Thanks so much for having me.
You're very welcome. You're very welcome. I had a little bit of help with the intro, and we have a great research team, so you're very welcome. Jan, could you kick off by just explaining a little bit about your background and what Edge Impulse actually does?
Yeah, absolutely. So I think it's really cool to be in the IT podcast. For me, the whole reason that I started doing embedded engineering was because I saw kind of the IoT happening from somewhere behind me, and I was like, okay, this train is so cool, I want to jump on it. So I was building connected devices already when I first heard about all of this back in 2013, but mobile phones. And at some point I wanted to have something that ran longer than a week on a battery, and then the only way, but still connected, so the only way you could go down was the embedded route. So I started building devices. Smart offices was one of the solutions that we started working on in 2015. And I thought it was so cool that I really wanted to shape kind of the future of this. So I went to work for ARM out of Cambridge in early 2016 as a principal engineer. And there I ran a software team that was kind of forward-looking. How do we think embedded developers are going to write software 5-10 years from now? And all of a sudden I realized that while we have lots of IoT devices all around us, they do very little useful stuff. There's so many temperature sensors that send a temperature value every hour to the cloud, but there's so much more data all around us. So we started building some embedded machine learning things to see if we can run ML on really tiny IoT devices. And yeah, after a bit of research, we actually realized we could, but it was really hard for embedded engineers to build that. So you kind of need a team of data scientists to really build a good solution. So about a year and a half ago, me and my co-founder decided to leave ARM and set out to build a company that lets embedded engineers really apply embedded machine learning to their embedded projects. So it's Edge Impulse, as you said, it's super widely used. We're 15,000 projects now. That number was from 2 months ago. It's absolutely insane in the amount of volume and projects that people start creating. But Edge Impulse is an engineering tool, a bit like an IDE, that helps you find correlations in sensor data and helps you understand the world a bit better through that.
That's fantastic. Yeah, so we share a similar background. My background is in embedded engineering at university. I went one way, you clearly went the other, but I know ARM very well, and that's really interesting. It must be quite daunting, I suppose, as well, really, Jan, to go out and fly the nest, as it were, and set up a business.
Absolutely, yeah. It's for me, I never thought of myself as an entrepreneur. As a technologist more, I really like building new things and trying to push the limit of what's possible. But I think the opportunity here was so big, and I see it as such a potential transformation for the way that we write software. Not that it will take over everything, right? It's just another tool in your toolbox, but it has a potential effect on the 30 billion MCUs that ship every year. That we figured let's actually do that and let's try it. And it worked out tremendously well. We're a year and a half old. We're 25 people now. It's you blink your eyes and yeah, the whole world has changed.
Yeah, absolutely. And I think that's that's a really nice problem to have, isn't it? Growth, especially right now, but through the pandemic and the struggles that other people have had in different industries. It's really heartwarming to hear of success stories.
Yeah, I think for us, it sounds a bit weird, but so we signed our lead customer in November 2019, right before COVID hit. But it's a customer in consumer health, and all of a sudden when pandemic hit, they realized they were sitting on lots and lots of data, and they were using Edge Impulse at that point to find correlations in sleep and do sleep classification. But all of a sudden they realized that lots of data about people getting sick and typical health patterns. So they started using Edge Impulse also to do COVID research. So that was for us a really great catalyst in terms of growing.
Yeah. And what is it that Edge Impulse, how does it differ compared to peers within the same industry?
Yeah, it's a hard question. So on one end, I think we're still trying to show people that embedded machine learning is possible. That a tiny MCU, a little camera module here, that a chip 1 square centimeter is actually capable of running some machine learning. And telling people about that, that is, I think, the biggest challenge. And it's not so much about competition at this point. The real competition we see is do it yourself. It's people that say, well, I've hand-tuned my DSP algorithms for the last 30 years. I can do better than an ML algorithm. And that's fine, actually. I think for us, we'll show you what's possible. We'll always try to tell you never trust what a machine learning algorithm tells you just by face value. Always add some checks, etc. In there. And so far, that seems to resonate quite well.
Sure. And is that from a technological standpoint, the microcontroller unit, is it because people believe that ML is usually based around quantum computing and large scale devices with lots of power, and so they're probably a little bit confused that you can actually start doing an ML on an MCU?
I do think that's the case, and that's where I came from, right? When in 2017, Neil Tan, one of my engineers at ARM, in a bar in Taipei, told me, "Hey, I got this machine learning model running on a Freedom K64F." I was like, "No way! Like, how do you do that? That's 256 kilobytes of RAM." But the thing that we realized is a machine learning algorithm is not special, right? During training, it requires lots of inputs and lots of outputs, and then it finds a hidden correlation, and that's a super expensive process. But what comes out of a machine learning model is just math. And the number of parameters that you have there, you can kind of control. So you can set the constraints of what you have in an MCU as kind of the boundaries of the formula that you want to find. But in the end, what a machine learning model finds is just mathematics. And MCUs are incredibly good at math. Like a typical Cortex M4F can do 40 million operations a second. And that's definitely fast enough to do. And we realized that is actually fast enough to do real-time audio classification, image classification, stuff happening all around you. And I think once people see that as a realization, they'll start realizing that yeah, you can actually do this on MCU and it's actually feasible.
Yeah, yeah. And for our listeners out there that may not understand, machine learning and embedded to perhaps the degree that you do, what are the use cases around embedded machine learning, and why is it important?
Yeah. Good question. I think what machine learning does is it finds a hidden correlation in your data. So let's say that you're building a control algorithm, and you want to know if water is cooking. So you have a temperature sensor, you put it in a pot of water, and you notice, okay, well, the temperature is 102 degrees and the water is cooking. Great. Now I cool it down to 98 degrees Celsius, and now the water is not cooking. Cool. I write a control loop. If temperature is above 100 degrees, then water is cooling. Works great. Now you deploy it to the field. Someone goes mountain climbing. He's at 2 kilometers height, and he looks at it, and according to your sensor, at 98 degrees, the water should not be cooking, but you observe, and it actually is. So there's a correlation somewhere between the altitude that you are, the temperature, and the cooking temperature of water. Machine learning can help you unravel that hidden correlation. So it is a tool, it's an engineering tool that says, well, I have lots of input data and I know what the outcome should be, but I can't find this correlation myself. I can't write this control loop myself. Then machine learning can help you uncover that. So you can do it on very simple use cases. So everywhere where currently you have a control loop, where data comes in and you have thresholds set up, and you want to respond to that, that's great. But you can also do much higher. You can also do things where a human can't really see this correlation. So audio classification. Do I hear glass breaking? Yes or no? Really hard to program it out if you have a waveform. Relatively easy for machine learning. Um, Image classification. So we have a super cool project with Smart Parks where they have a solar powered camera that takes a snapshot of the savannah, and when it sees an elephant or a poacher, it sends a signal over a satellite, because then a ranger should take a look. And then a super wide variety of predictive maintenance and machine monitoring use cases. Like, does this machine oscillate differently than all the other machines in my factory, etc. So anywhere where you have lots and lots of data, you know that there's somewhere a hidden correlation, or you can determine it yourself. But it's too difficult to write by hand. That's where machine learning helps.
Yeah. And would you say that was the main difference between ML-based, a more server-side projects and actually embedded machine learning, that real-time useful information that you can get from sensor-driven data?
I think it's also a bit of a personal preference. I think I think the world around me is so incredibly fascinating. So I want to write algorithms and I want to write devices that actually interact with that environment, rather than, and a lot of the way the machine learning has grown was in server farms, because they were dealing with data that was already on the server farm. Like, is there fraud in my credit card transaction? Yes or no? And that is really easy to scale, right? If you need a larger algorithm, you spin up a larger virtual machine in the cloud and you run it there. The interesting part with ML in the IoT sense is that you're very constrained by what the chip can do, that's sitting on there, what your MCU can do. If my model doesn't fit on this MCU, then I might either need to redesign, or I can't make my BOM or anything like that. So for me, this is much more interesting. It's and the sensor data all around us, and constrained environment, which is always fun.
Yeah, absolutely. And I guess, on that note, Jan, there must be quite a lot of challenges in developing embedded solutions for ML projects. What are the main things that you've come across in starting Edge Impulse?
So the main challenge that I think the hard part with machine learning algorithms is that there's always some sort of black box component, right? Because you can ask the machine to find you a magic formula that classifies things, but can you trust it? And that is important already if you deploy this in a server farm. We've seen lots of discrimination by ML algorithms, and it's really easy to point at the computer and say the computer says no, and that's already really bad. But this gets even worse if you start deploying that in millions of devices, where you don't even have control over the algorithm anymore, right? If I ship an ML algorithm in the control loop of an industrial system, I want to be very, very sure that it behaves exactly the way it should, even considering all the edge cases. So we try to help a little bit with that. So we try to visualize kind of the feature space of what we have covered. So we kind of can tell the developer, say, hey, there's kind of this whole class of potential data that you haven't uploaded or collected in your data set. Maybe you should do something about it. And we add some safeguards here. So we never trust the output of a neural network just by the face value, because neural networks are very unpredictable. They work really well on data that looks like anything they've seen before, but very poorly, kind of random, at data they've never seen before. So we typically use stuff like anomaly detection models next to it to say, oh, this looks like data I've never seen before. I'm not going to trust the rest of my ML algorithm. I'm going to alert an operator or send something off. And that explainability is, I think, really important if you're going to deploy this in embedded systems, because once you put it out there, it's out there. You can very often never change it, right? There's lots of devices that are never connected. And the last thing is, if you have a safety critical feature, just write it out by hand, please. Even as a last safety guard, right? And I think that's really important. It's an engineering tool. Don't treat it as a black box.
Yeah, got it. And it's interesting because one of the first questions that I asked you was, how does your business differ from peer groups? And you mentioned that really there isn't many peers. There isn't many people doing this. That's curious because it seems obvious. And I think, the age-old adage is, it's obvious when you know how. It was easy when you know how, right? Why do you think that your quite pioneering within Edge Impulse in putting ML on embedded devices and on MCUs. Why has it not been done before?
Yeah, so it's been done a little bit, right? But only by really large teams that consist of both embedded experts as well as experts on the ML side, as well as data scientists that know how to design for constrained systems. And because we probably all have a device in our pocket that does embedded ML all the time. The chip that is responsible to respond to Hey Siri or OK Google does not run on the main application processor. It's a separate DSP, really small side processor that runs all the time and just listens for the keyword. But yeah, only Google and Apple and Amazon have been able to really build systems that work really well in 20K of RAM. And for me, we realized that when we were at ARM, and we had this amazing research team that was capable of making the actual math run incredibly fast on normal MCUs. And then the only demo that we could basically get together was, oh, here's the pre-trained neural network, here's some predefined inputs, and now we'll print over serial, we'll print the output. And that's because if you have like this Venn diagram of data scientists know how to build these models here, and then you have embedded engineers that know how to build embedded systems here, there's no overlap. There's virtually no one that can do both of these things. But it's required to have these two people in the same room and have them speak the same language to build a successful system. So what we try to do with Edge Impulse is say, well, we're going to skip the data scientist here. So we're going to have we're going to talk about this from the perspective of the embedded engineer. So we always start with signal processing first. We've been doing on-device learning or on-device analysis for a long time. We just call it signal processing. Let's do that first, and then let's build some tools that help you get some of this data science knowledge into your own little bubble. And that allows embedded engineers to apply their knowledge to their problems. And that is much more useful. That you don't need to have this translation layer or this team of PhDs or the data scientist sitting next to you to help build that. And yeah, we're early with that, but I do think that this is going to be a tool that every embedded developer will have under his belt 5 to 10 years from now. Because it's so useful. But we're super early, yeah, absolutely.
Yeah, and that's useful that you mentioned signal processing, right? Because clearly this is key to embedded ML, isn't it? And again, for the benefit of our listeners that don't perhaps understand signal processing in the depth that you do, that maybe I understand a little bit, could you go into a bit more around that?
Yeah, sensor data typically is very noisy, right? So let's say I have a rotating machine, and I have a sensor on that, and that measures the acceleration. So if it's rotating perfectly, I'll probably see a graph like this, a sinus wave. So if I want to know how fast that machine is oscillating or machine is rotating, okay, so yeah, one step back. So you have the sine wave, but it's noisy because, well, there's lots of other stuff happening with the machine as well. So first I want to denoise this signal, just to make my life a little bit easier. So we can use a filter to do that, a standard signal processing thing. So we use a low-pass filter to remove kind of all this noise thingies. Then we're interested in, okay, well, I'm not interested in the sine wave on sich, but I'm interested to see how often these peaks happen. And so in signal processing, we use a fast Fourier transform to transform this into kind of time frequency data. So we see a peak maybe at every 2 seconds. So now we know already we've denoised the signal, removed everything we're not interested in, and we know that there's a vibration or a rotation happening every 2 seconds. That's already super interesting information. And very often that can be an indication of whether a machine is going to fail. If instead of every 2 seconds it starts to rotate every 1 second, there's probably something wrong with the machine. So we can use this as well in machine learning. So rather than give you this raw waveform, which is lots and lots of data, we clean up the data first. We do some basic analysis, the stuff that we've already been doing for the last 30 years. And that compresses the data a lot. So typically we have maybe 5% of the data left, of the signals left. It has cleaned up a lot of the data, so all the noise has been removed. And thus we can deploy much, much smaller machine learning algorithms.
Yeah.
That's how these two things work together, and that's kind of how we've been able to do real-time audio classification on really tiny MCUs or real-time machine classification on really tiny MCUs.
Yeah, fantastic. Thank you for that, Jan. And so I guess this begs the next question. Where can this go? Now that you're doing it, now that you're making it happen, I guess it's almost limitless in terms of the use cases and what you could do with it. But personally, for you and Edge Impulse, where can we see this going in the next 5 years? How is this going to affect people in their everyday life?
I think that every embedded engineer. Okay, so like how an RTOS is now a fundamental property of virtually every embedded device, right? How an FPU is now virtually a property of every embedded device. I think that embedded machine learning will also be part of that. It will not be something you use for literally everything, but it's something you have in your tool belt in case you want to solve a problem. And once enough people understand that, and once enough people have kind of the knowledge of where to apply this, they can start applying it to fields that we have never heard of or problems that we've never encountered. And I think that's where kind of the value of all technology is sitting in. Because even the 25 people in Edge Impulse or the 100 people that you guys have can think about all of this, but you need absolute domain knowledge on the field where you're actually deploying your device to really see where you can add that value. But from there, really the sky is the limit, right? So I think we're in a state where you can run, for example, vibration analysis algorithms, anomaly detection algorithms, some basic audio classification on any IoT device, kind of any brownfield IoT device even, which is really cool. But the development in ML are not standing still either. We're coming into the state. So this little device is a HiMax. It's a DSP. This thing can do 10 frames a second image classification which is insane. It's almost video, right? On a MCU class device. Can you imagine what you can do if your device can actually understand what it sees? Because right now the whole reason why we use accelerometers or temperature sensors or we have all this kind of surrogate sensors that try to guess the world. But if you can just look at what is happening, very often you can just see that. Like, how many people are there? Okay, well, here, snap a photo. Cool, I count the number of people. Is there a fault on my production line? I snap a photo of my product. I see if the screw is in or not. But I think that capability, that is going to be super transformational for devices. If you can do that low power on a battery in real time, I think that's going to be mental.
Yeah, well, I mean, that's a perfect example there. You have accelerometers on devices at the moment, so they're aware of it being moved and which direction, etc. But potentially you could remove that through ML, couldn't you? You could remove the need to actually have these additional features on said devices, perhaps making them smaller, cheaper to produce, perhaps.
Yeah, I like the analogy with a Formula One car. So while they're doing all the test driving, they try to stick as many sensors as possible on the car to get information about how the car drives. But and this is a really cool use case. I still want to build a demo around this. They introduced synthesized sensors at some point. So they realized that if I have sensor A, B, C, and D, and I remove sensor B, I can use machine learning to actually interpolate the value of sensor B. So I don't need to change my control loop, but I can have one device less on the car, which means less weight, etc. So that's one part. But I think there's lots of other things we can do exactly with this, right? There's so much more things that we can sense on our devices that we're currently either imprecise or not being able to sense at all, where ML can really help.
Yeah. Well, what about security, Jan? So often a lot of people see security as an afterthought. We're as a group of businesses, we're very much involved with things like the IOTSF and various organisations. It does potentially pose some challenges there, right? Because if the device can recognise people distances from an ML base rather than it being a sensor or some physical accelerometer or what have you, what are your thoughts on that and as a company?
Yeah, that's very serious concern. my main thing here is, if we're going to collect this kind of data and analyze that, let's make sure we actually process it on the device and don't need to send it to a central location, right? I'm relatively okay with, and that's mainly because I trust Apple, I'm relatively okay that my phone is listening for Hey Siri all the time, right? Because I know it runs on the DSP, only it never leaves the device. It would be much more, I would not like it at all if my phone was constantly recording, sending everything to Apple's location, analyzing for that keyword, and I'm telling that they throw the rest away. So I think that's one part. Try not to get data into a place where it can be stolen. I think for us as well, like if you deploy a model from Edge Impulse to your device, there's no link to us anymore. We just give you source code, right. But there's nothing that actually tracks it back to us. But yeah, there's a whole bunch of new privacy constraints and security constraints that come with the data that you process there that we need to kind of reinvent as an industry as well. But it's hard, right? I think someone said at some point, like the company that invents the green lock, the SSL lock for IoT, will become very rich, but it's an impossible problem to solve.
Well, yeah, exactly. Yeah. Well, impossible or improbable, right? I guess But it's interesting what you're saying, and again, for the benefit of people that are listening to this, so you're effectively what you're saying is, as long as the data is stored natively within the device and it's not sent up the cloud somewhere else, then that's a layer of security by design, which wouldn't allow interpretation or vulnerability to people hacking that, right? Because it's staying within the device, right?
I think it definitely helps. Definitely helps.
Yeah.
But yeah. Regardless, I mean, be considerate, right? Like, we have rules around, where you can put cameras, etc. And those rules don't fundamentally change in IT, but the chance that your camera is all of a sudden 2 square centimeters large and can do all the processing on device, that poses new challenges. I think also in society, in what do we accept as society, and what do we want with this type of data? That I think we have to figure out over the next couple of years.
Yeah, absolutely. But I think, the technology exists is fantastic, and we shouldn't lose sight of the technology, because what we can do and the pros and the benefits of this is enormous. But it's, you always have to think of that undercurrent, right? The underbelly of the dark side of this and what people could potentially do it for, and being attuned to that. And it's nice to know your thoughts on that and how your views are as a business around it, because so often sometimes, as I mentioned earlier, it's an afterthought. It's a gold plating exercise, isn't it? Right? You're doing it retrospectively, as opposed to thinking about it from the start, which I think in an ever increasing connected environment is going to pose some challenges, isn't it?
Yeah, so we require actually everyone to accept the responsible AI license before you can use us.
Okay.
Just, we think that AI should be used for good, and we try to be a company for good as well. And yeah, that also means for us that we won't work with certain companies. So offensive military, for example, we'll never work with that. We try to do a lot in conservation to give back. So we do some really cool projects on the African savanna. We're part of 1% for the planet, so we donate 1% of our revenue to that. We try to help with, I try to teach Data Science Africa every year. Unfortunately, not this year. To kind of help to bring some knowledge that way. So try to do our part, but yeah, it's hard as a technology company sometimes.
Yeah, it is, but I think the major hurdle is the fact that you're thinking about it and you're doing these things, and that you're wanting to work with companies that are in that mindset. Being involved with 1% of the planet, being involved with these initiatives, and often that's enough, isn't it? Because it means it's resonating with you already. So.
Yeah, it's never enough, but that's the thing. Like I said, I'm not at the beginning of the conversation. I said I'm not an entrepreneur, but this is the part of entrepreneurship that I really love. Right? This is, I think ARM is one of the companies that does this kind of stuff really well. They give you like a day or a couple days a year to work on volunteer projects, etc. But you always need to convince someone that something is a good idea or you should sponsor something. And being able to start your own company and put these type of things into the DNA of the company from the very start is, I think, super worthwhile. I think that's really cool if you start off your own to be able to do that.
Yeah, absolutely. Well, Jan, thank you so much for taking the time out to come onto the IoT podcast show. I really enjoyed it, and especially understanding more about your business. It's truly really at the cutting edge, isn't it? And I hope things go from strength to strength. In the future, it might be nice to get you back on when you're 50, 75 people, when it's being used across 20,000 projects. Well, 20,000 probably be next week at the rate you're going. Yeah. So maybe we'll go for 200,000. But it's exciting, and it's nice to hear good stories like this. So really appreciate your time.
Thanks so much.